Hey guys, welcome back to Chemistry TV. In this video here, we are going to look at what exam possible question in general chemistry 1. And this we are going to solve like 5 different topics in general chemistry. Although this is going to be the first video, so you are going to use this video as your revision or your preparation towards the exam. Believe me, some of these questions, most of the topic we are going to do here, and some of the questions we are going to solve in this video, you are going to see them in the exam. So make sure it's a long video, it's a lengthy video. This is going to be one of the most lengthy video I've ever done on this channel. So you will have to take notes. Make sure you are with your pen, your notebook, and your calculator to take every single thing down. So we are going to start with more concepts. So most of the question will be then what do the calculation. Yeah, if you are ready for this class, leave it at the comment section that you are ready and you are ready to what to blast your exam. The general chemistry 1 in some school they can call it Chem 130, some school they can call it Chem 101, some school they can call it Chem 111. It all depends on the code is being given. You get that? Most of this topic here will be under general chemistry 1. So it does not matter the school you are into. If you are in import, Uniben, Ignatius, RSU, any of the screen lag, then you really want to follow me closely because general chemistry 1 is the same in all schools. Do you get? So for now, I'm really going to focus on the Uniport style of question, which is going to be Chem 130. If you're a Uniport student here, leave at the comment section that you're a Uniport student because I'm doing this class in regard to your exam preparation. Do you get? So this video is really going to help you in your exam preparation. So make sure you stick to the end of this video. As I'm teaching you here, they're going to release some tips you can use to pass your what chemistry. So let's jump into it. So the first thing you want to look at is more concepts. The more concept. The more concept is the first calculation in chemistry you need to know and master because every other calculation in chemistry comes forward for the more concept. So here are what 4 questions we have to do. We have to solve these 4 different questions. Now, time will not permit to solve other questions, so I will leave a link at the description below where you can get exam possible questions. I will leave the link at the word description below. It's going to be free. Go to the description, download it and use it. Where I solve other questions. So calculate the mass of 8.2 exponential 21 molecular of CO2. Now, in solving more concept calculation, there are 3 basic formula you need to know. So the first one here, mole equals to what mass, or what molar mass. This is what the first one. We have mole equals to what numbers of atoms over what 6.02 6.02 exponential what 23. Now this atom can be a molecule. If you are talking about molecule, then here we have mole equals what volume of substance over what 2.4 dm cubed, or you can say 22400 cm cubed. So these are the 3 formulas we are going to make use of. Do you get that? So you always to what copy them out. Do you get that? So calculate the mass. When they ask you here, it will get the mass of what 8.2. So sorry, mass of what CO2 is okay. Mass of CO2 is what they ask you to look for, and they gave numbers of molecule, numbers of what of molecule to be what 8.2 exponential 21. So please follow me closely here because I'll be a little bit fast so that I can be able to what cover most of the topic we are going to cover in this video. Do you get that? So now what they say should look for is what numbers of molecule, which I'm going to use this guy. Numbers of what of molecule, right? Now, because we are talking about molecule, you remove the atom and we will place what molecule, right? Now, that are talking about mass, we are going to use one here because it contains mass about what molar mass. So it means that mole is equals to what mass about what molar mass equals to what numbers of what atoms. So I have to talk about numbers of what molecule here. over what 6.02 exponential what 20 what 3. Do you see that? Now, the main reason why I use on here, remember mole because what mass per molar mass. The same one you also see that numbers of molecular what 6.02 exponential 3. So we are able to make use of this guy here. Remember, we are looking for what? I will look for mass, right? So I want to use mass by what molar mass equals to what numbers of what of molecule over what 6.02 exponential what 23. So the next you want to do here is to what? Get the molar mass of what CO2. So how do you calculate molar mass of what CO2? Because you need what the molar mass of what CO2 here, right? So let me just put here molar mass of CO2. Because I don't want to write this place here. Molar mass of what of CO2. You get now. So let me just teach you how to what solve for molar mass because in your exam you must calculate molar mass. You must calculate what molar mass. So how do you calculate the molar mass? Now, first you want to do here is to what know the atomic mass of carbon. You get that? Know the atomic mass of what of carbon. The atomic mass of carbon is what is 12, and the atomic mass of oxygen is what is 16. So it's going to be 12 times 1 plus 16 times 2. If you sum it together, you're going to give what? 44 gram per what? Per mole. 44 gram per what? Per mole. So it means that the mass I'm looking for, mass of CO2 here, mass. Because I'm going to write it a little bit because I don't have too many space here. Mass over the molar mass of CO2 is what 44 equals to now numbers of atom. Remember numbers of molecules given to me, right? We were 8.2 exponential what 21, 8.2 exponential what 21 over, right? They have 6.02 exponential what 20 what 3. So if you make mass the surrogate of formula here, I want to write that place here. So if you should make mass the surrogate formula, if you cross multiply, what will happen here? Now you have to get mass equals to this times z divided by this, right? If when you cross multiply in normal mathematics here, we want to go to the 44 times 8.2 exponential 21, right? Divided by 6.02 exponential 23. So you have 44 times 8.2 exponential 21 over 6.02 exponential 23. So what you want to do here, so bring out your calculator. Please, I advise you to get this scientific calculator here. It's very important you get this because this is going to help you with a lot of things. Like going to help you solve so many things, get your answer accurately without you stressing yourself much. So it's going to be 44 times 8.2 exponential 21 divided by 6.02 exponential 22. So the answer is 0.599. 0.599 gram. That is the what answer. Do you get that? So we have done the what first answer. You can pause video and go over it again. You get. Then question 2. If you are following this video, please, I want the video to be interactive. If you're following this video, say it on the comment section that you are following what these videos. It will let you to understand that you are following. Always let's interact at the comment section. If you have any question, drop it at the comment section. You get that? After the class, I can go ahead and explain to you. Do you get that? I will also leave my link. I will leave the link to my direct WhatsApp so I can communicate with me directly. If you have any question, you can drop those questions there. So let's look at question 2. Question 2. You can pause the video and try to solve question 2 yourself because it's still the same format. Calculate the mass of 1.9 exponential 21 molecule of Cl2. You get that? Cl2. So yeah, I'm still going to use the same thing here, right? But yeah, if you check the question 2 just like question 1, the only thing you want to do here is to put Cl2. Because if you check very say calculate the mass of what? Of Cl2, chlorine gas, right? This is what I'm looking for. Now, when the numbers of molecule is being given to me, the numbers of molecule is what? 1.9, 1.9 exponential what? 21. It's okay. So you can go ahead and try and solve this thing for me. Leave your answer at the comment section. Leave your answer at the comment section. What is the answer to this question? You can pause the video and leave your answer at the comment section. So if you should work, make mass the sorry formula. Let me write this place out. So if you should make mass the sorry formula, mass is equals to what? Mass is equals to what? Molar mass times what? Numbers of what? Of molecule, right? Let me read it like that then. 6.02 exponential 3. Now the next one to do is to calculate the molar mass of what? Of Cl2, right? So molar mass of what? Cl2 is what? It's going to be, remember the atomic mass of chlorine is what? 35.5, right? So it will be 35.5 times 2, going to be what? 71 gram per mole, right? So that's what you want to do here. So it's going to be the molar mass. Now the molar mass is what? Is 71 times mass of molecule is what? 1.9 exponential what? 21 over 6.02 exponential 23, right? So if you use your calculator, you're going to get 71 times 1.9 exponential 21, right? Divided by 6.02 exponential 23. So the mass of what? Cl2 is 0.224 gram. That is the what? Answer. If you got the answer, leave like message that you got the answer. Is it clear? So let me do up question 3. Question 3. Question 3. If the mass of calcium chloride is 16.9 grams, so mass of what? Calcium chloride is what? 16.9 gram. This is that 16.9 gram. What is the mole? Asking of what of the mole? Mole of what? Calcium chloride. It's okay. Now we have to use this one here, right? Mole equals to mass for what? Over molar mass. This one is a little bit easier for us, right? So the only thing you want to do here is to what? Get, so it's all about the handwriting. So the only thing you want to do here is to what? Calculate what? The molar mass of what? Of calcium chloride. So molar mass of what? Calcium chloride. So calcium chloride is what? Is 40, right? Calcium chloride is what? Is 40. Sorry, calcium is 40 because the atomic mass of calcium is 40. 40 times 1 plus. Now chlorine is what? Is 35.5. So 35.5 times 2. This is that. So punch your answer so that you use your calculator to get your answer. 35.5 times 2 plus 40. So here we have 11. 111 gram per what? Per mole. 111 gram per mole, right? We are using what? Mass for what? Molar mass. So my mole here, my mole here goes to what? Mass for what? Molar mass. So if you should input your value here, my mass is what? Is 16 points. So let me just solve it here. So mole equals to what? The mass is what? 60.9. 60.9 gram over, here we have 111 gram per mole. So if you do the division here, Here I would have 16.9 divided by 111. So you have 0.152 mole. That is what that is the answer. I did a little question here. They said the volume of what CO2 at STP was found to be 2500 cm cube. So volume, the volume given to me is what 2500 cm cube. Do you get this? Is that? Remember, more can either be volume of substance or 2.4 dm cube or 22400 cm cube. So you can use cm cube. Can you use cm cube here? I want to use this guy. You see that? Then they're asking what is the mole? Mole. What is the mole? So it's very easy. We are just going to make use of this one here. So mole equals to what? Volume of what? CO2 over 22400 cm cube. Do you see that? So my volume given to me here is what? 2500 cm cube over 22400 cm cube. Same because I cm cube here. So what should be left with is what? 2500 divided by 22400. So you have 0.1116 moles. So these are all the questions under what mole concept. So with the knowledge of this one, you can go ahead and solve other what question. You get that? So like what I said, I want to leave a possible exam question on what I'm going to do today, and one of those things you're going to see in what in your exam. So we are done with what mole concept. The next thing we want to look at is empirical and what molecular formula. How do we solve that question? So let's get into it. So we are going to solve. Let's move to what empirical and what a molecular formula. This way I'm going to teach you how to solve empirical and what a molecular formula. So you want to pay close attention, and we are going to look at what two main questions here. So pay close attention to what I'm about to teach you. So now I say a compound is composed of 52.14% carbon, 30.13% hydrogen, and 34.73% oxygen. Now by mass. So we are being given the question by mass, composition by mass. Do you get that? So whenever percent by mass is being given to you, you regard it as what? As the what? As the gram. You get? So what is the empirical formula? What is if the mass of the compound is what 138.204 gram per mole, what is the molecular formula? Do you get? So let's talk about the first one here. So I'll be using like a table. To solve this problem. You get? So the first one to do here, the elements. The element give it to me. Just for me step by step, you understand. Element here. The element we have here, we have what? Carbon. We have what? We have hydrogen, and we have what? Oxygen. Do you get that? So these are the three elements you have. So I want you to go ahead, sum all these ones here. If it's going to give you 100, go ahead, sum all this one here. Sum all this one here. If you're going to give me what 100, it's going to give you what 100. So here we have percent by mass. Percent by mass. So someone is already going to give me 100. If he's going to give you 100, so leave at the comment section that give us about 100. I just want to confirm it here. Go ahead. Someone is going to give me 100. 52.14 plus 30.133 plus 34.73. Is that 100? 100. So that is everything here is 100. So it's called percentage what by mass. So it is when what the mass is like 100%. So you are going to use it a lot as mass in what in equation. So it's going to be 52.14 gram. Here we have 30.13 gram, and here we have 34.73 what gram. Do you see that? Now remember, the next thing we want to do here is what get the mole. So that is why it's very important to know the atomic mass. The atomic mass of carbon is what is 12. The atomic mass of hydrogen is 1. The atomic mass of oxygen is 16. So we want to get the mole. Remember, mole equals to mass over molar mass, right? So it will be 52.14 over yes gram over 12 gram per watt per mole. The same thing here, 30.13 gram over 1 gram per watt per mole. Then you have 34.73 gram over what 16 gram per mole. So you go ahead and divide this and get your answer. So here we have 52.14 divided by 12. So you have 4.345. 4.345 what mole. You see that? Then this is going to be 30.13 moles. Alright. So let me do for this last one 34.73 divided by 16. Give 2.170625 what mole. Now, my advice to you is that when you are solving, don't approximate at the initial point. You can only approximate when you get to the final answer. The next thing you want to do here is to get the mole ratio. Mole what ratio. And how do you get the mole ratio? So I can just do it like this. How do you get the mole ratio? You get the mole ratio by dividing by the what mole, the lowest mole. If you check it very well, you want to get the mole ratio, you have to divide by what lowest mole. How do you know the lowest mole? Here we have 4.345. Here we have 30.13 and what 2.170625. So this is what is the lowest mole. So you have to divide through this guy here. So here we have 4.345 moles over 2.170625. Can you see that? So the same here, 13.13 what moles over what 2.170625 what moles. Then here we have 2.170625 moles over what 2.170625 what moles. So what you want to do here, divide it and get your answer. 4.345 divided by 2.170625. So you have 2. You have 2.00, so you can leave it as what? As 2. Let this one here, 30.13 divided by 2.170625. So you have 6.0, so you can leave it as 6. Then you have what? 1. So my empirical formula here. Now, carbon is what is 2, hydrogen is what is 6, oxygen is 1. So go ahead and copy this to art. So now let me advise here. If you are going to solve a empirical formula in your exam and it's being given in terms of theory, so it's advisable to do it like this. You get. So what will be my empirical formula? The empirical formula here is going to be C2 because carbon is what is 2, hydrogen is what? Hydrogen is 6, and oxygen is what? Is 1. That is the word empirical formula. Is the word empirical what? Formula. Empirical what? Formula. This is called empirical formula is the word simplest formula. Is what? Simplest formula. Do you get that? So all is simplest what? Ratio. So this is what my empirical formula. Now, but the question is not just say you should calculate empirical formula. The question says you should calculate what? Molecular formula when the molar mass of the compound is being given to me. So I'm going to write this place here so I will be able to solve the molecular formula. So how do I solve my molecular formula here? I want you guys to pay close attention to what I'm going to do here. So the format here is going to be C2H6O1 N equals to The molar mass given to me is what? Is 138, 138 point what? 204. Do you see that? So the goal here now, this is the what? Molar mass of the entire what? Molecule. Do you get that? And this is just what my molecular what? My empirical what formula. So for me to get my this is just my empirical formula. For me to get my molecular formula, I need to calculate n. So n means that I'm going to multiply it twice one here to get what my actual formula. Do you get that? So the next I want to do here is to calculate the molar mass of this empirical formula here. Now, this one I'm seeing here is the molar mass of the full what? Of the what molecular formula. Do you get that? So I have to calculate the molar mass of this empirical formula and divide with what, and divide through so I can what get my n. This that. So if I want to calculate the empirical the molar mass of this empirical formula now, it's going to be 12 times 2 plus 1 times 6 plus 16 times 1, right? And here we have 138.204. So let's go ahead and summarize all this one together. Let's go ahead and summarize this one together. Here we have 12 times 2 plus 1 times 6. Yes, 1 times 6. Remember, here is 6 plus 16 times 1. Here we have 46. 46 what n equals what? 138.204. So making n instead of formula here. 138.204 divided by, yeah, so my n is going to be 138.204 over what? Over 46. You want to have 3. So my n is going to be what? To be 3 here. So what I'm going to do, my molecular formula is going to be what? Remember, you get my empirical formula, so it's going to be this 3. You're going to multiply everything here. So it's going to be 3 times 2, right? So 3 times 2 is what? Is 6 3 times 12 should be 18. Okay, 3 times 6. 3 times 6 is what? Is 18. 18, then what? Remember, here is 1. 1 times 2 is going to be what? Is 3. So this is what my this is what my molecular formula. So this is my empirical formula. This is what my molecular formula. So molecular formula is the what? Actual ratio of atoms in the what? In the compound. While empirical formula is what is simplest what? Ratio. Do you see that? So here's what the difference here. So you can pause the video and try this guy for me. Question 2. Go ahead, try that one for me, and let me see what you can actually what do. Go ahead, pause the video, try it for me. Leave your answer in the comment section. Please, if this video is helpful, and you're getting a lot of value from this video here, I am understanding what I'm teaching, please leave it at the comment section. Let's interact at the comment section. If you have any question, you can also leave it at the comment section. I'm going to respond to that. So you can still share these videos to your friends, share to your various departments. As I said before, share to your various departments. Also, you are also preparing for their exam. Do it now. Share it. Copy the link and share it in your various department. It's very important to do this. I would have said this earlier on, but I didn't say it. But it just get into my mind now that I should say it. So share it to your various departments. So they can join this class. So question 2, a compound consists of 20.32 gram of carbon, 5.12 gram of hydrogen, and 7.9 gram of nitrogen. What is the empirical formula? Yeah, the first one they gave us what? Percentage by mass, right? Yeah, they gave us mass straight, so you can go and use the mass straight and solve it. So like what I told you, I want to get the elements. Here only have 3 elements. 3 elements? So here we have 20.32 gram, and here we have 5.12 gram. Oh, sorry. The elements are carbon, hydrogen, and what? Nitrogen. So the mass are 20.32 gram. Here we have 5.12 gram. Here we have 7.9 gram. Right? So this is what is the mass. The next one to do now is what? Get the mole. Right? Remember, mole equals of mass or what? Molar mass, right? So the atomic mass of carbon is what? Is 12. So it will be 20.32 gram over what? 12 gram per mole. Here, 5.12 gram over what? 12 over what? 1 gram per mole. Here we have 7.9 gram over what? Remember, here is nitrogen over what? 14 gram per mole. It's very important you know the atomic mass of each of these element is very important. So the next thing you want to do is to get your answer. So here I have 20.32 divided by 12. So here I have 1.693. 1.693 watts mole. This is that 1.693 watts moles. Then you have 5.12 watts mole. Then you have 0.9 divided by 14. 0.564. Can you see that? 0.56443. So we can leave to what? 4 decimal points and above. So it's too late, so can you leave 4 decimal points and above? The next you want to do here is to what? Get what? The ratio. And how do you get the ratio? Divide by what? Lowest what? Mole. Here we have my mole here 0.564. So it's going to be 1.693 moles over what? 0.5643 what mole. Can you see that? So the same thing here, 5.12 mole over what? 0.5643 what moles. Right, same thing here, 0.5643 moles over what? 0.564 what moles. So let's do the calculation. 1.693 divided by 0.5643. So you have 3. Here we have 5.12 divided by 0.5643. Here we have 9, and here we have 1. You see that? So my empirical formula now, let me write this out. My empirical formula is what? Is C3H9 and what? N1. So you can just move the 1 there. And that is what my empirical formula. You can see as it is, right? The next thing you want to do here is to what? Get my molecular formula. Get what? My molecular formula here. Get my molecular formula. So remember, to get the molecular formula here, I know what my molar mass of the compound, right? The molar mass of the what? Entire compound. I only know the simplest formula here. So it's going to be C3H9N1 equals to what? The molar mass of the compound will 236.448. Can you see that? So the goal here is to look for the molar mass of the empirical formula. Now, like what I said earlier, this is the molar mass of the molecular formula. Do you get that? The entire what? So the goal here is to get my N. So if I can get my N, I can easily look for the molecular. So I can look for what? The molecular formula of what? Of the compound. So let's calculate the molar mass of this empirical formula here. So it's going to be 12 times 3 plus what? 1 times 9 plus 1 times uh, 14 times 1, right? And equals to 2, 3, 6, dot 4, 4, 8. Guys, that. So let's do this one together. So 12 times 3 plus 1, 1 times 9 plus 40 times 1. So you have 59 and equals to 236.448. So my n is going to be 236.448 over 59. So you have 236.448 divided by what? 59. So you have 4. Can you see that? So the answer is what? Is 4. So how do I get my molecular formula? By multiplying this, right? So molecular formula is very easy. Molecular formula is very easy. So it's going to be 4 times 3. 4 times 3, 4 times 3 now is what? Is 12. So it's going to be C12. Let me confirm it first. 4 times 3 is what? Is 12. Then hydrogen, 4 times 9. 4 times 9, you have 36. You have what? 36. Then nitrogen is 1. 1 times 3 is, no, 1 times 4 is 4. So this is what my molecular what formula. So you can see how it is. Like what I said, I will drop a complete possible exam questions on the what on my link there. You can go ahead, download it, and use it for your personal what study. This is how to work, calculate what empirical what and molecular formula. If you get value from this video, if you are getting value from this video, always believe that you are getting value from this video and you are getting what I'm teaching. Please, if you have not leave any comment at the comment section, please leave now that you are following this what video. So the next one I want to look at is reacting masses, which is called stoichiometry calculation. After that, I want to look at what molar. You see, I have so many things to do. So make sure you stick to the end of this video. And if you have not shared this video to friends, so please do that to share the link to your friends now, so that they too can be part of the what class. You get that is the only way you can promote this channel. So let's look at the next one. Let me towards stoichiometry calculation, and this is one of the stuff you cannot actually escape in your what in your exam. It's under what reacting what masses. If you look at your past question, you have seen questions like this. Do you get that? So I have to what teach you what step by step on how you can what get this here. Remember, this one is a revision question, so you really want to what pay close attention to what I'm about to do in this what uh pay attention to what I'm about to do here. So if you are solving any question that involve reacting mass, that involve equations, do you get that? So maybe say how many gram of this we produce when this react to the mass of this, do you get that? Almost. So you really want to what the first one to do is to what get a balanced chemical equation. And this question here, I'm giving us what a balanced chemical what equation. One thing I want you to understand is that we have different type of method in solving this question, but I have a more specific type of method that is more easier than every other method. So if you pay close attention, you find that you'll be able to solve this thing here. Look at something here. Look at these two questions. Say calculate the mass and mole of Fe, iron, which is iron, that we produce from 12.5 gram of what iron 3 oxide from what from what the reaction. Look at the reaction here. You get that? Now, if you check me very well, the mass of what iron 2 oxide, iron 3 oxide was given to me. Now, the mass of CO2 was not given to me. So we are using what the mass of C2O3, which was iron 3 oxide, to calculate what the mass at the mole of what of iron. Do you see that? Now, if you checkmate what question 2, determine the mass of what NH3, which is ammonia produced from a mixture of 190.88 gram of N2 and what 4.00 gram of what H2. If you checkmate it very well, you find that 2 mass was given to me. mass of what H2 and what mass of what mass of what N2 and what mass of what H2. So these two questions look alike, but they are not the same. Now this one just like normal reacting masses, but this one is under what limiting reactant and what reactant what in excess, which I'm going to explain to you more. But if you don't understand if you don't understand, so if you cannot solve this type of question, there is no way I want to what solve this kind of question. So your attention now, your focus, and your goal here is to what ensure that you understand this word, because that will not give me what that will now give you a sound knowledge or idea or foundation to solve this what problem. So no matter how bad you are, so just pay close attention to me. So the first one to do is what write out the balanced chemical what equations. So you have Fe2O3 plus 3CO2 giving you what 2Fe plus 3CO2. This is that. So after you write it out, you want to write what the balanced mole and what balanced mass. So here we have mole and here we have what mass. In solving any reactive mass question, this is the first one to do. Write out what your balanced mole and what your balanced mass. So how many moles do we have here? Here we have one mole, one what mole, one mole, one mole, right? How many moles do you have here? Here we have three moles, three what moles. Now how many moles do you have here? Here we have two moles, two moles. And here we have what, three moles. You see that? So the reactive mole are very easy to get. And next to get what the mass. And to get the mass, you need to look at the molar mass of each of the what of the elements. So you look at what Fe2O3. Now it's a question that I want to give you what the atomic mass of each of the elements. Do you get that are involved in the chemical reaction? Now the atomic mass of iron is what is 56. Atomic mass of iron is what is 56. So it will be 56 times 2 plus 16 times 3. So when you sum them together, 56 times 2 plus 60 times what 3. Here we have 160. Here we have what 160. 160 gram per what per mole. What does this mean? It means that for every 1 mole of what of Fe2O3, I have what 160 gram of what of Fe2O3. So this is what you want to what, put in mind. Do you get? Now how many more do you have here? Here we have 1 times 160. Here we have 160 what gram. So like what I say, we have different methods in solving this type of problem here. Here is what the most simplest method in solving this question. Now the next you want to do, what you have done, you're still going to do it here, and what here. Here is what CO, carbon monoxide. Here we have what CO2. So just a little correction there. Now the next one to do is what is CO. CO, carbon what monoxide. So the molar mass of what? Molar mass of what? CO, carbon monoxide. We're going to be what? 12 times 1 plus what? 16 times 1. What are you going to get? So 12 times 1 plus what? 16 times 1. Here we have 28 gram per what? Per mole. 28 what gram per mole. What does it mean? It means that for every 1 mole of what of CO, I have 28 gram of what of CO. That is the what? That is the meaning. So how many moles do you have here? Here we have 3 moles. So it would be 3 times 28. 3 times 28. Here we have 84. 84 gram, right? Now Fe is what is 56. 56 times 2. 56 times 2. Here we have 112 gram. Now CO2, if you calculate what the molar mass of CO2 is going to be what 44. So 44 times 3. Here we have what 132 gram. Now, so this is the first thing you really want to do. Yeah. Then therefore say calculate the mass of what Fe. So mass of Fe, which is what iron. This is what they say should what calculate, right? And they gave me what mass of what iron 3 oxide. So mass of what iron, which is what Fe2O3 is what Fe2O3 is 12.5 gram. Can you see that? Now, if you check it very well, now this is Fe, this is what Fe, right? And they're talking about the mass. This is what is the mass, right? Fe2O3, which is this guy here, they're talking about what the mass. So for the balance relationship, for the balance equation here, 160 gram of what Fe2O3 is equal to what so from here I can say 160 gram of what Fe2O3 is equal to what 112 gram of what Fe2O3. Can you see that? So you really want to pay attention to that one here. How do I get this? It's very easy. From the parameter given to me to solve with. Now they ask me about what is the mass of what of iron. If you come to this place here, the mass of iron is what? Remember here we have mole and what mass, right? The mass of iron is what 112 gram, right? And this one here Fe2O3, they gave us the mass of what Fe2O3, which is what 160, right? So going to be 160 gram of what Fe2O3 equals to 112 gram of what Fe2O3. Do you see that? So for the word balance what equation, that is why if you can do something like this here, you have eliminated about 3 to 4 steps that you are supposed to take when solving normal method. Now the next thing you want to do here is what use your dimension analysis to what complete what the calculation. So remember we are solving for what mass of what Fe2, right? Mass of what Fe. So we are calculating what mass of what iron, which is equal to what? Now remember they gave us mass of what iron 3 oxide, 12.5 gram of what Fe2O3. Now because I'm using dimension analysis method here. What I want to do here, I want to have numerator and what denominator. Now I'll just say over 1. Do you see that? Times. Now in dimension analysis, one thing you want to put in your mind is that you are the one that will arrange in a way that you can get what the accurate answer. In the sense that you need to arrange that because this one you have got now or you have written down, you need to arrange in a way they are going to cancel out each other. Do you understand? So in the sense that I'm not arranging because gram of Fe2O3 is already at the top. I will arrange in a way so that it can move to the down so that they can what cancel out. Here we have Fe, not Fe2O3. Of what F what E. It's a little bit is just a correction there. So this guy will move to the down, why will move to the top. So there are 2 ways I can do this thing. Is it that this guy go to the down or go to the up? But you are the one that will arrange such a way that they will cancel out each other. In the sense that this guy need to go to the top, 112 gram of what Fe. This is that the wise one need to go to the down. You have 160 gram of what Fe2O3. You can see that this guy can cancel out this one here. This is that. Now, but if you do it other way around, there's no way you can cancel out. So in dimension analysis, in this last step, you are the one that will arrange in a way they will cancel out. You understand? So what will be the final answer? So I want you to just use your calculator to get your answer. 12.5 times 112 gram of F112 divided by 160. So what will be the answer? 12.5 times 112. So you have 400 divided by 12.5 times 112 divided by 160. Here we have 8.75. 8.75 gram. That is the what answer. It's okay, that is the what answer. 8.75. So the mass of iron produced in the reaction is what 8.75. Do you understand? So the next one to look at what is the mole of what Fe produced. Using the same what mass here. Do you understand? So don't just what know your relationship here. Now the main reason why I use one here because the mass of mass of iron is what they say should look for. So the mass of iron is what 112 grams. And we have been given what mass of iron 2 or iron 3 oxide, which is what 12.5. So because I'm using mass here, it's going to be 160 gram of iron 3 oxide equals to what 112 gram of iron. So what I want to do here is just arrange in a way they are going to what cancel at each other. So it is the relationship I want to arrange in a way they are going to cancel each other. The main reason why gram of Fe2O3 should go to the down so that they can cancel at here. As simple as that. Do you understand? If you are following this video, leave at the comment section that you are actually what following this video. So let's solve for the mode. We are done with the math. Let's solve for the mode. How do you solve for that mode? How do you solve for that mode? And we want to write so hard. So yeah, but now we are not talking about what mode. So mode of what Fe. How do we calculate the mode of what Fe now? Do that. Now, remember in the first one here, we use mass to mass relationship, right? This one now is not going to be like that. So we're talking about mole of Fe, mole of iron. So when it comes to this place here, remember here we have mole and here we have mass. So we're talking about Fe. The mole is what is 2 mole, right? We circle it out 2 moles. This is that 2 what moles. Now, the main reason why I circle out the first one here, they talk about mass, that's why we circle out this one here. But now they are not talking about mass, they are talking about what mole. So we circle out 2 moles. Do you understand? Now they're still talking about mass of what Fe2. So you also come here and look at what the mass of what Fe2. We are not going to go to the mole here because they talk about mole. We are still using the same mass. So it's now going to be what 160 gram. So from the relationship here we have 160 gram of what Fe2O3 is equals to what 2 moles of what Fe. Can you see that? Hope you understand now. It's still the same pattern here, but here I'm not using mole. Now, the same dimension analysis here. So remember, we are looking for what mole of what Fe. So it will be mole of what Fe is equal to. Now here we have 12.5 gram of what Fe2O3 over what 1 times. Now 2 mole of Fe will be at the top. Why is one go to that so that you can easily cancel out? So here we have 2 moles of what Fe. Here we have 160 gram of what Fe2O3. You find that this one we cancel out this guy here. What am I left with? I'm left with so 12.5 times 2 divided by what? 12.5 times 2, right? Divided by 160. So you have 0.15625 gram. That is the what answer you get. So you can see how easy it is. You can solve problem using this simple what method. Now, like what I said, I'm going to leave a possible example question in the comment section so that you can go get that stuff. You can use for your what own personal what study. So that is it. If you understand the first one, you please leave at the comment section that you what follow. Then question two is what is going to take our time a little bit. But with this foundation, you can now solve. You can now understand this thing fully. So this I'm going to explain limiting reactants and reactant necessary. And this way I'm going to explain so many things to you. Just want to close here. So I'm also going to give you a shortcut or a short method on how you can what easily get limiting reactant and what reactant necessary. If, for example, now the question is saying, if for example, the question is in subjective or objective, so there's a way you can get limiting reactant essay straight without passing through so many procedures here. But for the sake of theory and for the sake of you trying to understand chemistry, I want to explain it step by step. So let's look at question 2. So question 2. Look at what question 2. Determine the mass of what NH3 produced from the mixture of what 19.88 gram of N2 and 14.400 gram of what H2. Now, this question you are seeing here is limiting reactant and reactant what in excess question. So you really want to pay close attention to what I'm about to explain to you. So the first one to do is what get a balanced chemical equation between N2 and what H2 to produce what ammonia. So you have H2 plus what N2 give us NH3. So the next one to do is to write out what the balanced chemical what equation. So this is what balanced chemical equation. So when a question is being given to you in some question in the exam, the balanced equation will be given to you just like what I've done here. But in some question, the balanced equation might not be given to you. So you have to what know how to write a balanced chemical what equation. So of course you are not going to do that here because it's not part of what you are going to do. Now, if you are still having issue with balancing reaction using the algebraic method, I've done 2 videos on that I can explain that for you. So if you want to check it out, I'll leave it at the comment section. It's okay, so I can check that stuff out or at the description so I can go check out that video. So the next one to do here, remember, is what for every stoichiometric calculation or reacting mass or reacting mole, the first you want to do is to write out what the balance mole and what mass. That is the stuff you want to do. So how many moles do you have here? Here we have 3 moles. 3 what? Moles. How many moles do you have here? Here we have 1 mole. Here we have what? 2 what? Moles. This is that. And next one to do is yes, so what? Get the mass. You get the mass from the balance what? From what? H for the molar mass. Remember H2 is what? 1 times 2 is what? 2 gram per mole. Right? For every 1 mole of what of H2, here I have 2 gram of what H2. That is the what is the mean. So it's going to be 3 times 2, which is going to be a 6 what gram. It's very important. The same thing with what N2. N2, what we want to do is what 14 times 2, which is what 28 gram per what per mole. The next thing you want to do now is to what 1 times 28, which is going to be what 28 gram, right? Then NH3 is what 14 times 1 plus what 1 times 3. Here we have what 17 gram per mole, right? So 2 times 27. So 2 times 17. 2 times 17. Here we have what 34 gram, right? That is what you need to do here. Now, from the question they're asking about the mass of NH to produce mass of what NH3 produce. Yeah, we are being given mass of what H2 and mass of what N2. Do you understand? So yeah, only mass of one of the compound was of the reactant was given to me, but here the mass of 2 reactants was given to me. That is not a problem. So I'm going to use the mass of N2 and H2 to calculate what mass of what NH3 using the same procedure I've done in the first one. That is the reason why I say you should what understand that first one, this first one I've done here. That will give you a clue on how to what solve this one. So this one is just like you are solving 2 calculation. You are solving NH3 with what 19.88 gram of what H2 and 4.00 gram of what H2. You are going to get 2 mass of what of ammonia produced. One is going to be for what nitrogen. One is going to be for what hydrogen. Right. So this is the first thing we want to do before I'm going to show you on how to get the limiting reactant, the reactant in excess, and what the mass of the product produced. So now mass of what N2 given to me is what 19.88 what gram. Then mass of what H2 here is what is 4.00 gram, right? So the goal here is to look for the mass of what NH what produce, right? So I want to wipe out this place here because here is no longer needed again. So I'm wiping out. So the next thing I want to do here is now we want to use the mass of this guy here to calculate so that one here, right? So mass of what NH3 and mass of what H2. So that is the first thing we want to do using that method we have done. Now the mass of N2 is this guy, and the mass of what NH3 is what is one here. So it means that 28 gram of what N2 is equal to what 34 gram of what NH3. That's the what the meaning, right? Remember, you're looking for what mass of what NH3. So going to be mass of what NH3 is equal to what? Now, what is mass of N2? Mass of N2 is what? 19.88 gram of what? N2 over what? Over 1. Can you see that? Times. Remember, I told you that you had want to arrange in a way that are going to cancel each other, right? Because gram of what N2 is all I saw. This guy would go to it down. So you have 28 gram of what N2. Can you see that? So just say what the simple dimension analysis you need to what do here, and it's very easy. Since gram of N2 is all I top here from this one here, from the relationship you are written at between these two things here, this guy will just move to down. Right? So here we have 34 gram of what NH2. What you have to divide this. So use your calculator to get your answer. So here I have 19.88 times 34 divided by what 28. Then we have 24.14 gram of what NH2. This is that. So it NH what 3. It means that I have used this one here to calculate this guy. Now the same here, right? The same here now. So I'm going to use this guy to calculate this guy here. For the balance relationship here, 6 gram of what H2 is equal to 34 gram of what NH3. So here we have 6 gram of what H2 is equal to what 34 gram of what NH2, right? Now remember, the mass of H given to me is what? Is 4. So remember, we are calculating what mass of what NH3. NH3. Mass of what NH3 here is equals to what? 4.00 gram of what H2 over what? Over 1 times. Can you see that? So this guy will move down, so move up. So you have 34 gram of what NH3. Then you have what 6 gram of what H2. Because this guy you cancel out with this one here. So what do I have left? So here I want to get my calculator. 4.00 times 34 divided by 6. So here I have 22. Here we have 22.667 gram of what NH2. Can you see that? So here you can see that. Here you can see that 90.88 gram of what N2 produce what? Produce 24.14 gram of what NH3. And you can see that 4.00 gram of what H2 produce what 22.667 gram of what NH3. Do you see that? So you need to what write some out like this. From here now, Now, the main reason why I love this method here because here you can get the limiting reactants. In some questions, they say, what is the limiting reactant? What is the reactant in excess? And what is the amount of the product produced? Now, in this question, they're asking what is the gram or, yes, what is the mass of ammonia produced? Now, to solve this here, the mass of the ammonia produced or the mass of the product produced in this type of question is always what the least amount calculated or the least mass calculated. Do you understand? Because these two are not the same. This guy is higher than this other one here. So you not be confusing. You not be confusing. Which one is what is the amount of the ammonia produced in the reaction? The amount of the ammonia produced in the reaction is always what the least amount of the what the smallest amount of what of the what or the smallest amount or mass of the product produced. So now the amount so the mass of NH3 produced is equals to what? 2.667 gram. That is it. Now it is what is simplest amount. Do you get that? Now for me, I can get the limiting reactant and the reactant in essence. If they ask now, what is the limiting reactant? What is the limiting reactant? Now the limiting reactant is what is the reactant that produces what the least amount of what of the product. So the limiting reactant is H2. Is okay. This one is the limiting what reactant. Then the amount in excess or the reactant in excess is what? So reactant reactants in excess is the one that will produce what the highest amount of what of the product. So N2 produces what the highest amount of the product, H2 produces what the lowest amount of the product. The one that produces what the lowest amount of the product is what is the limiting reactant. While the one that produces what the highest amount of the product is what is the reactant in what in essence which is what N2. Do you see that? Okay, now let's look at this question. This is a regular question you normally see in the exam. So I'm going to teach you a simple way you can identify limiting reactants. Now, the first one we have done is maybe you are solving a theory what problem. Do you get that? But what about if you have limited time in the exam and it's subjective or objective? How are you going to do that? So they say determine the limiting reagents in the what reaction if 4 grams of calcium carbide are mixed with what 2 grams of water. So you don't need to do so many stuff here. What you want to do here is to calculate what the mole of each of the stuff here. Right there. So the first step now, because this step is just for you to what easily get the limiting reactant and the reactant in what in excess. Just that is it. So what we want to do here is get the mole of each of what of the reactant, calcium carbide and water. So molar mass of what calcium carbide, the molar mass of calcium carbide is what? The molar mass of calcium carbide is 40 times 1 plus 12 times 2, right? So what are you going to get here? 40 times 1 plus what? 12 times 2. Here we have 64 gram per watt per mole, right? So molar mass of water, molar mass of what? H2O is what? 1 times 2 plus what? 16 times 1. You're going to be 18 gram per watt per mole. This is that. So the next one to do is to what? Calculate what? The mole. So mole of what? Calcium carbide is going to be what? Mass over what? Molar mass. So the mass is what? 4 gram over what? The molar mass is what? Is 64 gram per watt per mole. So you have to divide it. So 4 divided by 64. What do you have? Here we have 0.0625 watt moles, right? Next is what? Mole of what? Of H2O. What are you going to get? It's going to be 2 gram over what? Over 18 gram per watt per mole. So you have 2 divided by 18. You have 0.111 mole. Do you get that? So to get the limiting reactant, now you have to what divide each of this one with their what coefficient. Now, what is the balance coefficient of what of calcium carbide is what is 1. If it's divided by 1, the mole is what is 2. Water is what is 2. You get that? So here you are going to get 0.0625, and you're going to get divided by 2. Here we have 0.05 or 6. Do you see that? So in the sense that the simplest mole. Now, the simplest mole is going to the simplest mole, the element, or sorry, the compound that give what the simplest after you divide by their coefficient is going to be the what limiting reactant. While the one that gives the highest is going to be the what the reactant in what in excess. Do you understand? So if you check me very well, we have calculated what the mole of each of the what reactants, calcium carbide and water, right? They now where they are getting from is for the balance coefficient. So I divide by 1, I divide by 2. So the one that have what the least value is what is the limit to what reactant. Why the one that have what the highest value is what is the reactant in what SS. So it means that H2O is the limiting reactant. I get it. Then calcium carbide is what is the reactant in what in excess. So this is a simple way to what get what the limiting reactant and what reactant in excess. Do you understand? So from here now, I really will get what my limiting reactant and what reactant in excess. So if for example here you are being given a question and is what objective, so you can easily what use this one to what get your what your limit what reactant. So if for example now they ask you what is the amount the of the product produced in a reaction, what is the amount of the product produced in a reaction? You use what the mass of the limiting reactant to calculate what the mass of this other one here. Just so that is it for this other one here. So from here now, this method here is just to what know how to what get the limiting reactants and reactant in SS without you solving much from what from the balance for what for the mole. You get when you get the mole, just see what the mass given to you. Now after you calculate the mole, divide by what by the simplest what divide by what by the coefficient. The coefficient of what calcium carbide is 1. The coefficient of what water is what is 2. Now here about my various mole here. So the next thing you want to do here is to what look for the one that have the least mole. This one have what the least mole. So that the one that have the least mole is what is the limiting what reactant. So it is water that what that produce the least mole here. So it's the what limiting what reactant. This one here, the calcium carbide is one that produces what IS is what reactant is what in excess. Do you understand now? So these are what simple way you can what know your limiting reactant, reactant in excess just from what from the mole. That is it. So we are done for this particular what video. Now the part 2 of this video revision question, exam possible questions. So we are going to look at what the structure of the atom, isotopy, atoms, proton, neutron, and electron. We are going to look at quantum number, question of quantum number. Then we are going to look at periodic table and electronic what configuration. So these are the next thing we are going to look at in the what in the next exam possible question. Do you get? So make sure you don't miss that. If you have any question, leave it at the comment section. If this video is helpful, always say this video is what is helpful and you get a lot of value from it. Thanks for watching. See you in the next video.